Let's figure out how many bonds oxygen can form using the periodic table. Now, the periodic table is arranged in groups, and you can see here I have some of the group numbers highlighted in blue. So this is group 1, group 2, group 13, and so on. These group numbers that are highlighted in blue are part of the main group elements. And for these, the last digit of the group number will tell you how many valence electrons the atoms in those columns have. So here with group 1, the atoms in this column have 1 valence electron. In group 2, 2. In group 13, remember we take the last digit of the group number, so that would be 3 valence electrons. 4, 5, 6, 7, and 8. Now, if our question is about oxygen, we can see that oxygen is in group number 16, which has 6 valence electrons. And if we remember the octet rule, atoms want 8 valence electrons in order to be happy and stable, just like the noble gases. So in order to go from 6 to 8, this oxygen will require 2 electrons. Let's draw the electron configuration to show this better. So with 6 valence electrons, we have 1, 2, 3, 4, 5, 6. So here we can see that there are 2 pairs of paired electrons right there, 1, 2, and 2 single unpaired electrons. Now, each of these unpaired electrons can form a bond by sharing with another atom's electrons. So if we shared with another atom's electrons, it could look like this, in which now you will see that the oxygen is happy because now there are 8 electrons in this valence shell. So the oxygen is happy. And this is why oxygen forms 2 covalent bonds, one for each of the unpaired electrons. We can see this in water, and here you can see that oxygen forms 2 single bonds with hydrogens, so that's 1 bond, 2 bonds. And then here in oxygen gas, you can see that there are 2 oxygen atoms, and they share this double bond, in which case that is 2 bonds. So you can see that both of the oxygen have 2 bonds. So remember, group 16, 6 valence electrons, 2 unpaired electrons, and that leaves 2 bonds for oxygen. Thanks for watching.